Okay, let's go ahead and go over this stuff and then we'll get into some more examples. So finding a particular rate can be quite the challenge if the equation is in terms of multiple variables. So if we could substitute some variables out and get the equation down to one variable, the derivative becomes a lot easier to find. But sometimes the problems can be a little overwhelming with lots of numbers, variables, verbiage, and other information running around. Um, so to help get things organized, you can put all of your data into three categories. It's one of the biggest things on these word problems is that you read it and you're just like, what the heck am I even doing? So this kind of helps dissect it and kind of helps it get organized so you know exactly what you have and you know exactly what to find. All right, so we have three categories. So category number one is stuff that you know. So what general equations or formulas do you already know that relate to the problem? Now, these are things that you have learned in previous classes. Not like the specific stuff in the problem itself, but like what formulas and stuff have you learned in pre-calculus or algebra 2 or geometry? So those things would be like area formulas, the area of a square, a rectangle, a circle, etc. You also know how to find a perimeter. You know how to find the volume. You might need a refresher on the formula, but you still know how to find it. You know how to use the Pythagorean theorem. Trig functions, you know how to use those. The distance formula, the slope. It's stuff like this. These are formulas that you already know coming into the class. Okay, so what of these would actually apply to the question at hand? All right, so that's category number one. Category number two is the given. So this is the specific information or data that is given in the problems. And typically it's a numeric value. Like they say, hey, the height is 3 inches. Or they give you a relationship between the variables. So like the height is twice the base or something like that. So it's stuff that they had to tell you about and not stuff that you knew before reading the problem. All right, so the know, the given, category number three is the find. What does the problem ask you to find or solve for? Okay, so I'm going to set the problems up with this. You don't have to do it if you don't want to. You can solve it however you want as long as your math is good and you have the right answer. But I kind of like this, especially in the beginning, because it does help kind of get things organized and helps you look for stuff you need to find. All right, example 2. The radius r of a sphere is increasing at a rate of 2 inches per minute. So find the rate of change of the volume when r is equal to 6. Okay, so what formulas might apply with this stuff? Like what formula do you already know kind of coming into the problem that would apply here? Well, that would be the volume. And the volume of what? The volume of a sphere. So the volume of a sphere would be 4/3 pi r cubed. Now, if we were actually in class on an on-ground class, I would expect you to know these, but for online purposes, I guess great if you know it, but since you get to use your notes and stuff, you probably don't need to memorize the volume formulas for shapes. You can just look them up. All right, so that's the know. What are you actually given? Like what numbers did they give you? Well, that said when r is equal to 6. Okay, and then it's increasing. The radius is increasing at a rate of 2 inches per minute. Inches per minute. That's a rate. Well, what's at the rate of? The radius. So since it's the radius, that's dr dt, and that is what equals 2. So dr dt is equal to 2. Okay, and then the find. What do they want you to find? The rate of change of the volume. So rate of change of the volume, dV dt. If it was rate of change of the area, dA dt. The rate of change of the perimeter, dP dt, and so on and so forth. Okay, so here's your stuff. If you're going to try to find a dV dt, you need to take the derivative of something. Well, where do you have an equation that has a v in it? Well, that's going back up to the no. So the no equation is what you're going to take the derivative of. Don't start plugging in your numbers yet. You got to take the derivative first, and then you can start plugging stuff in. If you start plugging in these numbers here, you're going to end up with a number as a result, and its derivative is 0, which doesn't tell you anything. So get the derivative, and then we'll start plugging in stuff. So dV dt is going to equal the 4/3 pi, that's just a constant. So the derivative of r to the third would be 3r squared times dr dt, because remember, you're still using that implicit stuff. So we took the derivative of an r, so dr dt. We took the derivative of a v, so dV dt. Okay, now you can start plugging in your numbers and simplify. So like the 3's cancel. So r was 6, dr dt was 2. So if you multiply that out, you get 288 pi, and we have inches in the problem, so let's give or units in the problem, so we need units in the answer. So volume is a 3-dimensional object. So its unit needs to be cubed. So inches cubed per minute. So volume is always going to be inches cubed per minute. The rate of change of the area would be squared. And if it's just a regular length, like the radius, then there's no exponent on it. It'd just be inches per minute. Okay. So that's the first one. So don't panic if you're just like, oh my gosh, what's happening? These do take practice. So just kind of watch this over again, see where everything goes. Just remember, where a lot of students get tripped up is they start plugging in the givens right away. Hold off on that. You got to do a derivative first before you start plugging in your values. Otherwise, you're gonna just kind of go around in circles and not know where you're going. Okay, so let's stop the video here, and we'll start with example 3 in the next one.